details. So Tim is a research scholar here in the Woodrow Wilson School in the STEP program, where he's been for 7 years, 8 years, yeah, roughly. He's also a senior research fellow at the World Resources Institute. Tim is probably best known, at least according to my opinion, for being the slayer of biofuels. And his work has been very influential in terms of looking at the actual net greenhouse gas emissions of biofuels, particularly our ethanol-based varieties. Now he's moving on into larger issues of climate change impacts and how to reduce climate change emissions due to agriculture written large. And I collaborate quite closely with Tim, so I'm very biased. I think he does excellent work. I've done my best.
That's very good.
I'll keep it brief, and please carry on.
Thanks. Yes, I'll try not to feel slighted by the fact that no one was scheduled to introduce me, so thank you, Lindsay. So actually, while biofuels are continuing my work, my day job is basically how do you feed the planet without destroying the planet? And particularly, how do we produce all the food that we're going to need by 2050 and beyond with acceptable greenhouse gas emissions. And I've given other broader talks on that, so this is going to be focused particularly on livestock. So today, the basic understanding is that agriculture contributes around a quarter of all the world's greenhouse gas emissions. And about half of that is through to the production process. So it basically comes from methane and nitrous oxide and energy use in agriculture, but primarily methane and nitrous oxide. And then about another half of that comes from land use change. That's what that LULUCF means, which is basically the way we count the expansion of agriculture into forests, the savanna, in order to produce more food. And these numbers are very rough. They're much rougher than that 13% gives you impression, but a quarter is probably roughly right. Now, when you start breaking down those emissions, about half of them are associated with ruminant livestock. What's a ruminant livestock? Cow, sheep, goats. These are things that eat grass. And ruminant livestock actually produce a very, very small percentage of global calorie consumption. But they produce about half of all of those greenhouse gas emissions. This is the methane that's produced in the stomachs of ruminants when they digest, which is why they're basically able to digest grasses. And this is the nitrous oxide that comes from the urine and manure they deposit on pasture land. Then a small portion of this manure management number, which is the methane that's released and little nitrous oxide released from the concentrated manure, most of that is pigs, but a little of that is dairy. So if you actually added all of that in, you're pretty much roughly around half of all agricultural greenhouse gas emissions in the production side. And they're more than half of all of the land use change. So because I want to go into more detail, but agriculture occupies about half of all the world's vegetated land. And of that, about 2/3 is grazing land. And so the expansion of agriculture has largely been to feed more animals, and particularly ruminants. So here's our challenge. By relatively conservative estimates, we're going to need 80 to 90% more beef and dairy by 2050. That's from 2006 baseline. Now we're a few years later, but actually it's going to keep growing even after 2050. So if you're already producing half of all the world's your production emissions from basically beef and dairy, and you produce 80 or 90% more, how do you deal with that problem? And in fact, again, I'm not showing you this slide because I've got too many slides already, but agriculture is on a trajectory when combined with land use change to probably produce around 12 gigatons of CO2 equivalent by 2050. Now that's less than energy use today, but if your goal is to hold climate change to 2 degrees C in 2050, the total emissions from all human sources, actually I'm sorry, not 12, they're about 12 now, they're up to about 15. The total emissions from all human sources need to be around 21. So agriculture is going to produce about 70% of all allowable human emissions. That's the trajectory by 2050. So that gives you the challenge. You have to produce 70% more food, and if agriculture really wanted to do its fair share, in reducing emissions, we'd have to produce 70% more food with a third of the emissions. We'd have to reduce emissions by 2/3. So that's why I work on what I work on, and why more people should work on it. And so here is what's actually happened in land use. We actually, since the early 2000s, there's been a huge expansion of harvested areas. This is of the 15 major crops, which didn't actually expand for about 20 years. It's been growing like crazy. So this isn't just theoretical. And pasture land has also been increasing. This slide. I don't know what happened to this slide. But it looks like it's declined in recent years, but that really has to do with a redesignation of drier grazing land in Australia, basically they call it desert. So pasture land has been increasing, cropland has been increasing. And one question, so just a few backgrounds. Why is it that land use challenges are often underestimated? I'm just going to give you a couple of reasons. One reason is that most of the time people are ignoring pasture land to begin with. They're really only focusing on cropland. So you see estimates that basically only focus on cropland. But another reason is even for cropland, this is a slide from a very good paper. Actually, I'm sorry, I didn't have a citation here. You're seeing the paper. And basically what you see is that yield gains are linear. So while yields grow at different rates at different times in different places, when they grow linearly. They don't grow as a compound growth rate. And so you'll see modeling estimates that essentially project future growth, assuming that yield growth is compound. So therefore the amount of growth increases year after year. And these are various papers that would use compound growth rates to project the future. But with linear growth rates, you're going to need a lot more land. Another reason is that frequently, and this is even true of IPCC papers, they will only tell you how much forest they think will be converted, not how much total land. And the assumption has been that if you're not converting forest, this even is literally true in the 2001 IPCC report, and it's been kind of copied a little bit since, that they only counted carbon released by converting forests. So you actually saw projections that we need more agricultural land, we'd have more land for bioenergy, and we'd even have more forest. You said, well, where's the land coming from? And the answer was that there was this big broad category called other. And what's other? So if you think of the non-forest land that is capable of producing food that isn't already in food production, it's basically wetter tropical savannas. And so they literally just treat it as though they were free. So Lyndon and I had a paper last year in Nature Climate Change where we did lots and lots of stuff, but really the basic point was very simple. We wanted to look at how much carbon is actually released by producing, if you were to produce food on particularly the wetter tropical savannas of Africa, which is a lot of the targets on. And we asked the question, is it even likely that they will release less carbon per ton of crop than the typical cropland? And we even assume pretty high yields. Yields are about 2 or 3 times above what people get today, just what their potential yields might be. And we basically found that only about 2% of the land could produce corn with less carbon release per ton of crop than the average cropland. And even with these high yields, about 11% of soybeans. And really, all we were really just pointing out is that tropical savannas are not free. They have a lot of carbon, there's a lot of actual tree cover in them. They also have a lot of biodiversity. And so for the bottom line of that is that a lot of mistakes have been made in global documents, including by the IPCC, simply because they just assumed that tropical savannas were free. Okay. So the last thing I'll say, kind of as background, is I don't know, did any of you recognize this chart? So this is kind of in the global agriculture world. This is a famous chart. It was the chart in the 2007 IPCC report that estimated mitigation potential in agriculture. And I'm not going to try to give you all the detail, but the key thing is that all that red is some form of carbon sequestration. And the focus was primarily on trying to get carbon back into the soils of grazing land and crops. And the idea was 90% of that could come by, of the mitigation in agriculture could come by doing it. Now I won't go into it in much detail, but basically there was almost no science and virtually no economics to support this charge. And it continues to live on today. And one of the things that's happened is that we now have had lots of papers pointing out how hard it is to get carbon back into soils. Some of it is that many of you probably are aware that the idea is that the shift to no-till cropping, where you basically don't plow with the soil, there was a belief that that would actually sequester a lot of carbon. Well, it turned out that the studies that showed that were only looking at the carbon very much in the top 10 centimeters. When you look deeper down, you either got no gain or a very small gain. But actually, there was also a remarkable basic accounting error. And that was that people said, well, look, there are lots of practices that can put more carbon into soils. If you add manure to soils, if you mulch trees, if you add more carbon to soils, you will get more carbon in soils. And that's true. But the question is that carbon has to come from somewhere. So we already have a certain amount of manure. It's already sequestering carbon somewhere. And just adding it to one soil rather than another doesn't increase the total amount of carbon. And if you cut down a tree and you mulch it, you can add carbon to the soil, but at the expense of the carbon of the tree. And while it seems hard to believe, that's literally true. That was really the analysis for a lot of these carbon sequestration opportunities. So that's wrong. But what you should see is that if 50% of the production emissions are ruminant livestock, and 50% of the total emissions from agriculture are land use change, clearing more land, then we know what we should be focusing on. We should be focusing on trying to produce more food without clearing more land. And we should be trying to figure out how to meet that demand, or that expected demand for meat while producing fewer emissions from livestock. So it's kind of obvious, and that has not gotten enough focus. So let me talk now about livestock. Because livestock are a big driver of the land use change, as well as, of course, this 50% of the production emissions. So take a step back. There's nothing new about the idea that livestock are a very inefficient way to feed people. Right back in the 1970s, there was a paper called Diets, a book called Diets for a Small Planet. Vegetarians know, but there are lots and lots of papers on this. And but the one question is really how is it? And on both sides of the argument on the efficiency of livestock, there have been a lot of, I think, basic theoretical errors. So, on the people arguing against, the people arguing against livestock, they point out the fundamental issue of poor conversion efficiencies, and that's true. And I'm going to show you stuff about that. And they basically say, look, if we all ate, or one of the arguments is if we all ate the same food that we now feed to livestock, we could come close to feeding the world. And in fact, there was a paper by John Foley in Nature in 2011 that basically made exactly this argument. So he called something called the diet gap, and he said, how much could we increase feed in the world if we simply took all of the corn and soybeans that we're now feeding livestock and we ate them ourselves? And that was a big paper in Nature, and it's a lot. But the pro-livestock people have pointed out a few things, which is the kinds of feed that we feed to livestock have a lot higher yields than the feeds we typically eat ourselves. So corn, for example, has about 5 times the yield of lentils or other pulses, so some of the alternatives, vegetarian alternatives of protein. And vegetables, from a pure caloric standpoint, tend to have relatively low yields. So they say that's actually a very misleading argument, because people don't eat corn and soybeans generally. If you're a vegetarian in a wealthier place, you eat other kinds of high resource products, vegetables, pulses, things like that. The other thing they point out is that livestock eat a lot of human inedible foods, right? So a lot of waste foods go to livestock, a lot of crop residues, brewers' yeast, and there's a lot of land that livestock use that couldn't be used to produce crops. So you'll see analyses that just try to look at the efficiency of livestock eating human edible crops, excluding the inedible crops. And in fact, actually, a lot of the arguments against livestock also agree with that. They only compare the crops, the efficiency of converting crops, and not the grass. And then there's a third argument, which is, hey, actually, livestock protein is easier to ingest, so you need to kind of score it up. You know, it's not the same as plant protein. Okay. Now, I think all of these arguments, well, I think this argument is correct. And one question then is to actually look at that in detail. I think these arguments are incorrect. Why are they incorrect? Well, first let me go to the, okay, let me take a step back while they're incorrect, and I'll show you what this slide is. So it is true that livestock eat a lot of human inedible foods, and they use a lot of grazing land that we couldn't use to produce food otherwise. But the issue is not, do we get rid of all livestock? The issue is, what is the effect of consuming livestock at the margin? So if you individually decide, I'm going to eat beef, or I'm going to eat chicken, or I'm going to eat lentils, what's the global effect of your decision to do that? And the basic story is, we've already used all the world's natural dry grazing land. So when people produce more beef and dairy, it's not because they're using more dry grazing land that couldn't be used for some other purpose. The way they do it is you convert land either for grazing land or for crops. So the fact that livestock use a lot of human inedible feeds doesn't matter because we're already using them. And at the margin, it's got to come from new land. And when you count all of the food that goes into livestock, you'll see extraordinary inefficiencies. So for beef, calorie in versus calorie out, I'm going to keep coming back to that, is 1 to 2%. It takes 100 calories probably on average, somewhere between 50 and 100, depending on people's estimates, calories of feed in all different types of feed produce 1 calorie. Others are a lot more efficient. I'll keep coming back to that. And here's another issue. People try to end this argument about more digestible protein. Well, it turns out that in the wealthier world, we already consume way more protein. So for those of us who eat way more livestock products than we eat, we're not consuming them because we really need the protein. We're consuming them because we like them. And so actually replacing animal products with anything else is no threat from a protein standpoint. Okay, and here's this point about the grazing land. So the big marginal source of beef in particular has been expansion of grazing land in Brazil and other parts of Latin America, where it basically expands into forests. And that's why we care about it. So one of the things I wanted to do was analyze this efficiency correctly, recognizing that diets we need more land and more emissions to produce things like lettuce and vegetables than we do corn. So recognizing the legitimate part of the pro-livestock argument, but also recognizing the illegitimate part. So we built, I won't give you a long story, but we spent 3 years working with a bunch of different other researchers. The principal modeler is Patrice Dumas with CIRAD in France. And we built a model that analyzes global land use in agriculture. And I won't go into detail because that's less what you're interested in. But the key thing about that model compared to other global models is we left out the economics. And that also allowed us to put in a lot more biophysical detail. So there are a lot of global models that govern with these papers that use a lot of economics. Why do we leave out the economics? Because they're mostly making stuff up. And particularly when you're predicting 2050. Nobody knows 90% of the parameters and functions that go into those models have almost no empirical basis. And particularly when you're trying to predict what's going to happen in 2050, things like costs, nobody knows. So we wanted to ask questions that you can ask, like, if we know what the yields are, if we say what we think the yields are, and we say what the diets are, how much land do we need, what the emissions are? So when you specify exogenously the key factors, what are the emissions and land use demands likely to be? And so, and just this is, I don't bother looking at this too much, but one of the contributors was our own Xin Zhang in the STEP program, and she contributed a lot of very detailed analysis of nitrogen here, so I'll just add. So now I apologize for this because it's supposed to be vertical, but I couldn't figure out how to make the vertical slide vertical when I pasted it in. So you can look at it this way. But here's what you get. I'm sorry, this is what I want to focus on. So here's what you get. And here's what you see is that notwithstanding, so here, if you look at this light brown are the production emissions from agriculture. And I probably have a slide just showing that. And you can see that when you can look at the production emissions per calorie, the production emissions are in fact significantly higher in general for all meat products than they are for vegetable products. This is per ton of protein. Rice is actually still, the emissions are quite high. But beef, sheep and goats are off the charts. But here's the key number I want you to focus on, is this dark brown. Now, the dark brown are what we call the emissions from land use change. And when you factor those in, we get much, much higher numbers. Now, what are the emissions from land use change? So these are the implicit emissions. These are the emissions that are likely to occur if you add 1 ton of protein consumption for beef. That's the additional land using today's production techniques you would need to convert to produce 1 ton more of protein. And that number is really large. And when you actually translate that, this is per gigacalorie, and it's even more from a gigacalorie standpoint. A gigacalorie is roughly the amount of calories that you consume. And when you translate that into, and I'm going to focus on this one a bit, when you translate that into the implicit emissions from land use change in a typical US diet, here's the production emissions, and you have to look at the scale. That's getting 1.3, getting close to 1.4 tons of CO2 per person per year for America. But the implicit emissions from land use change are like 15. Now, the energy emissions of a typical American are around 18 gigatons. That's from the production side of the United States. That's a little bit of an unfair comparison because this is more global emissions to feed us. If you look at the global energy emissions to supply Americans with all the things we use, it's probably 21 to 22 tons per person per year. Let's say gigatons tons per person per year. Sorry. And this is actually, when you add these two together, it's like 15, 16 and a half, 17. Your dietary decision by this type of analysis has almost the same impact on global emissions as your energy consumption. Now that number is much higher than what you typically see. So let me explain why. It has to do with the way we account for things. So when we kind of estimate your energy emissions for a person, and let's say for the whole planet, the assumption is that if we didn't consume energy this year, there'd be no energy emissions. And so we count all of them. But when we look at emissions from land use change, the typical way it's done is not to start from a zero baseline. We start from whatever land use was used last year. So think about it, if there were no change from year to year, if the population didn't grow globally, if we didn't change our diets globally, there would be no land use change emissions. Now, does that mean that your decision to eat food has no land use impacts? Of course not. So if magically we all stop eating, then that huge amount of land, that half of the world's vegetated land that we converted to agriculture would regrow forests. In fact, the eastern United States is basically regrown forest where it once agricultural land use. But in the real world, we're actually converting more land. And that means that even as, and so then why isn't that amount of land that we convert each year a much larger number? Well, the answer is that even as we increase our food consumption, yields go up. Most of the drivers of those yield gains are simply technological progress. So in fact, if we didn't actually consume more food every year, the amount of agricultural land we need would decline. So all this is backward to saying we then want to have what is the implication of a single person's decision to eat food, to exist, right? Or to eat one kind of diet rather than another diet. And if you estimate that by the amount of land that is needed to produce that amount of food, you then end up with a much, much larger. And it's so large that even if there are some people, particularly bioenergy defenders, who believe or argue that as we increase demand for crops, there's a big response in that farmers just boost yields on existing land. There's a very broad consensus that most of yield gain is driven simply by march of technology. We can talk about that if you're interested. But even if this were half, even if half of that food, your particular individual demand for food, were met by farmers boosting yields on existing land, this would still be a gigantic number. So I think actually the first interesting take-home message is that actually our individual dietary decisions have close to, or at least a really, really large impact on the order, getting on the order of all of our energy consumption when you factor in the land use. Okay, so then when you start looking at changes in diets, and again, lots of other papers are doing this. So this is all going to be in a paper that initially will come out with the World Resources Institute, and then we'll turn it to an academic paper. And depending on the dietary assumptions you use, you can save a lot of land and a lot of emissions. Now, each of these have their own kind of individual definitions. And so the ambitious beef reduction, I want to just focus actually on these in particular, because I think these are the most realistic. The typical American actually consumes about 1/3 less beef today than we did at the peak of American beef consumption. The same is true of Europeans. And even shifting to pork and chicken, let alone legumes, could have a very large impact. This does not mean eliminating beef, but if we were this particular scenario, if Americans were to change their beef consumption so it met the global average, and then continued to consume just as much meat but did it in the form of pork and poultry, you could still get quite a large reduction in the amount of emissions and land use. Okay, so this is almost unreadable. Use it as a prop. Unfortunately, we didn't produce the right chart like this, but the bottom line for this, though, is that that is not true globally. Why? Because globally, let me jump ahead. Globally, this is how much calories per day a typical American consumes from livestock products. So think about this as the average American consumes, this, including all the waste, about 3,500 calories per person per day. So about a third of that, a little less than a third of that, comes from livestock products. Look at this. Only about 100 come from beef and mutton. So 1/35 of our calorie consumption, and yet that's the cause of about more than half of all of our contribution to greenhouse gas emissions. But around the world, people eat a lot less. So when you think about the benefits of dietary shifts, you have to recognize the fact that for a lot of people, we actually want to eat more. We want to eat more meat. Particularly in Africa, where that's the equivalent of like 1 glass of milk per day, 1 glass of whole milk today. of course, that's mainly consumed by the wealthy, not by the less wealthy. And there's a lot of health benefits to consuming some livestock products if you're consuming very few. So the bottom line is that that large gain in land use and greenhouse gas emissions that could come if the wealthy of the world reduce their food consumption does not translate into the same percentage gain on a global basis, because there are billions of people who we don't want or can't expect to reduce their livestock consumption. Now, one of the things we haven't produced, I hope to have produced, but we're still futzing with, is that over time, people are going to eat more livestock products in 2050 here, and then the question is more people, the world would benefit even more from their dietary shifts, but I can't give you those figures. But right now, the bottom line is that we don't get a huge percentage shift. But if globally just the wealthy reduce their beef consumption to the global average, it would still be enough to come close to eliminating the need for additional land as we go to 2050. So when you think about diets, part of the message is beef, above all, really is inefficient. And we can have a large effect if we can reduce our beef consumption. Okay. Now, having said that, that's only going to get us so far. So then the other question is, how do we produce beef so it has fewer greenhouse gas emissions? Now, there's actually some good news here. So this is I don't know, somehow or other, I get through it all. So this was a 2013 paper, and the data set for this we incorporated into the model that I've been showing you. But here's what I want to show you. This is the greenhouse gas emissions per kilogram of protein in beef. And this is kind of it's not quite a logarithmic scale, but it shoots up, let's put it that way. So look at the emissions that are in Africa. And Africa and India have a lot of cows. And the emissions there are upwards of 1,000 or 750 in case of India. Kilograms of CO2 per gram of protein. Now in the U.S., they're 50 and below. In Europe as well. Now why is that? And by the way, I spent a lot of my life fighting a lot of the excesses of U.S. concentrated livestock and all the pollution that they create and all the antibiotics that they use. But from a greenhouse gas perspective, they're incredibly efficient. And why is that? The reason is that if you feed an animal just barely more than what that animal needs to survive, you need to feed it a lot just to keep it alive. And that generates a lot of greenhouse gas emissions, a lot of land use demands, while producing a small amount of beef or dairy. So while it sounds horrible, the fact is the most efficient production is the production that gets the most amount of milk and meat per annum, basically. And then it actually is also quite sensitive. The methane emissions are actually quite sensitive to the specifics of the diets. So we know that part of the solution is that if we can get the developing world to produce meat, it doesn't have to go anywhere near as far as American concentrated systems, but just produce meat and milk more efficiently. We can both reduce greenhouse gas emissions a lot per kilogram of meat, milk and meat, and reduce a lot of land use. And the good news is, as I said, it doesn't have to go to American-style systems. Anyway, I'll show you what that means later. Okay, but here's the other issue. So we want to increase the efficiency of livestock production in the developing world. And in theory, if you don't increase your demand for milk and meat as a result of doing that, you'll also save a lot of money. However, we have a paradox. Here's the paradox. So for a long time, Norman Borlaug, the inventor of high-yield wheat, the father of the Green Revolution, he kept pointing out that the Green Revolution was great for the environment because by increasing yields, it reduced demand for land. And then others, these guys were a couple of economists at C-PREE, which is the forest organization. They would put out stuff saying, hey, actually, in a lot of countries where they increase the yields, you don't actually reduce the amount of agricultural land. So in Brazil, there have been huge increases in yields, and yet there's also been an increase in the amount of agricultural land. Now, that's actually not a huge mystery. And the reason is that when you're a poorer country and you become much more efficient at producing food, you can grab a larger part of the global market. So Brazil became more efficient at producing soybeans and more efficient at least shipping beef to the rest of the world, and they got a larger market share. So while their yields went up, their market went up so much that they expanded land area. Now that means that's part of a global shift in where we produce agriculture. And as Brazil expands its ag land, Europe and the US have actually contracted until recently, the agricultural land. And actually some of that land reforests. But it's not a fair deal from an environmental standpoint. Why? Because when you clear land in Brazil, you're talking about huge biodiversity effects, huge carbon effects, and per ton of yield is lower. So we don't actually want land to shift. We want yields to increase in the developing world, but we don't want them to then become the exporters to the rest of the world necessarily, particularly of crops that use a lot of land, as opposed to high-value crops that maybe use less land for more dollars. So, what's the deal? The deal that we want is, the global deal is that the world helps developing countries improve their yields, in both not just of crops, but livestock products. And in return, they have to agree not to clear more forests. And we have one example of where that's kind of happening due to lots and lots of things going on, and that's Brazil. Now in Brazil, they cleared 200 million hectares of land in about a 30-year period, 175 of which are used for very low quality grazing. To give you some idea, that's roughly equal to all the cropland in the United States. And Brazil realized that it could dramatically intensify. It could produce huge amounts more beef, dairy, and crops on existing agricultural land. And at the same time, it came under enormous international pressure and consumer boycotts for clearing land in the Amazon. And through a combination of that self-interest, public pressure, real concern for forests within Brazil, et cetera, basically a decision was made, hey, we're going to clamp down on clearing land in the Amazon and focus on intensification. And this is actually explicit in Brazil's climate plans. Now, one reason they could do it is they cleared a lot of land. But we want more countries to do it. And so a lot of my work is trying to make that deal explicit, provide the tools that allow you to make that kind of planning explicit. So a big part of my work is something called the Agricultural Synergies Project, where it's developed tools to analyze the intensification potential of livestock systems around the world, and then what that would do for production, for land use demand, for greenhouse gas emissions, and for profitability. And that turns out to be a lot harder than it sounds. When we put up these global data, like that study I showed, the Herrero paper, it makes it look like we really know what we're talking about. And that paper is probably right in the very rough sense. But the truth is, we have amazingly poor data on what actual farms, different types of farms are doing in different countries. Even the national numbers for data, even the amounts of land is a huge challenge. So we've spent 3 years building this tool, and we've been focusing one big place is in Colombia. So I'll just give you some of the results from Colombia. So Colombia makes Brazil's land use look efficient. So about 90% of the agricultural land in Colombia is used for grazing, and it's only got slightly more than half a cow per hectare. Hectares are 2.5 acres. Because it's so efficient, the Livestock Association itself has endorsed the goal of reducing its grazing area by 10 million hectares, by a quarter, even while doubling production. So there is a political sense that's in the country's interest to actually intensify its livestock and even use some of that land for use. So we actually, one reason we started working in Colombia was that the politics are kind of already there. But there's also the reality. The reality is that Colombia is still clearing 150 to 200,000 hectares of land. So you have this political commitment at this level, and then the question is, how do you translate that into reality? And of course, we can only do so much as technical people. And I'll just jump ahead. Let me go back here. Sorry. So basically, we built this integrated modeling system that starts by requiring that you actually divide the country into separate regions, and then you characterize the typical types of production systems in quite a high level of detail in each region. What they're eating, what types of cows you have, what their mortality rates are, what their milking, called lactation rates are, and the precise feed qualities of the key feeds that they have. And it takes a lot of detail because actually all of those things really matter. And once you characterize those systems, we built this integrated modeling system that then estimates what the production is, what the emissions are, and what the land use demands are, among other things. And then, from on top of that, we can then estimate by looking at other types of farms in the area how you can improve things. If you had one kind of feed rather than another kind of feed, let me just jump. I'm going to cut all the detail here. Let me jump to this. So what can you do to improve livestock systems in Colombia? So, first of all, you can improve the type of grass. So some types of grasses, if you plant them, improve them, and fertilize them, you can have much more output and much higher quality output. You can also rotate cattle. So instead of putting them all out in one place, you move them around very quickly, and that tends to stimulate both grass demand and the quality of their feed. You can give better health care that reduces the mortality rate and increases the fertility rate. You can provide a key factor in livestock productivity is in most of the world you have dry seasons. And in dry seasons you don't have as much feed. And when you don't have feed, they lose a lot of weight. So you can supplement in the dry season, either with crops, with crop-based feeds, or even grass that you preserve. Now the ultimate system that is happening in Colombia is something called the intensive silvopastoral system. And this is what it looks like. And it combines very high quality grasses with nitrogen fixing shrubs that provide virtually all of the nitrogen, and then tree layers that help keep in the humidity. And these are everybody's dream of what agriculture should look like. They've got carbon, they've got an amazing amount of bird life in them, and they're like 10 times as productive per hectare. However, there are only about 10,000 hectares of that because it takes a huge amount of management. They're very profitable, but it's a very different type of system than what a typical farmer would do. Now, if we could get what are probably about 40,000 hectares of that in the whole world, maybe 30,000, and if we could make that 30 million, the world would be a much better place. That's a huge step to break that happen. So then, and one of the things you discover when you analyze the system is that even within Colombia, there are huge differences in efficiency. So look here. Basically, you have regions where the emissions per kilogram of protein are about a fifth or a sixth of the less efficient regions. I'm running out of time, so I'm going to move fast. And when you look at like this region, which is a big producing region, but very dry and very inefficient, even there, you discover there are enormous differences in efficiency. Now, this is the key number I want you to focus on, which is kilograms of CO2 per kilogram of protein. It's not even counting the land use. And basically, what you discover is that you have much more efficient systems simultaneously with much less efficient systems. So then, we're just kind of racing through this. You can look at potential improvements. And what you discover is that things that are quite practicable can dramatically reduce both the emissions per kilogram of protein. Look at this difference between these intensive silvopastoral systems and typical low management today, and the output per hectare can dramatically increase. So another part of our analysis, I'm going to run out of time, so I'll just go real quickly, is then to look at, well, where would you do that? Because not all of the grazing land you want to improve, some of it's environmentally sensitive. But when you look at the kind of areas that you want to not improve, you still end up, the bottom line is you end up with a lot of land that you can still improve. I'm going to show you some of these other numbers, and then when you look at the areas that are biophysically suitable for these improved grasses or these intensive silvopasture systems, you also have a lot of land. Not all, but a lot. And here's, and then you can also look at where you want to reforest. But here's the thing I want to get to, is that, so one of the things our tool does is it allows us to say, well, how much would you benefit on a regional basis or a national basis if you could get 10% of farms to adopt one level of improvement, 20% of farms to adopt that, what about the second level of improvement? You can do mix and matching. You can do scenarios. And this is basically roughly a 10 to 15% improvement. It's a little complicated. This is roughly a 30% improvement. Roughly divided between kind of one step and two steps. And what you could see is that within that dry basin, you can get a significant, even by getting 30% of the farm area to improve, you get a large reduction in emissions per unit of protein, and well, you can't really see it here. I guess it got cut off for whatever reason. You can also get a substantial reduction in land use demands. But here's what I'll jump to. So we analyze this on a national basis. And again, this roughly 30% improvement, half of which is really pretty basic, and then the other half is more advanced, would, among other things, it would increase production so much that if you took half of that production gain and said, well, we're going to include that as Colombia's production increase, and then used half of it to save land, you would be able to save almost 6 million hectares of land. And then, if you took half of that and reforested it, you can get very large carbon gains over time. And in fact, I don't know what happened on this line, I'm sorry. But the bottom line, it's hard to see, so just kind of ignore this line. I don't know why. Is that this became, some of our analysis became the basis for a nationally appropriate mitigation action plan by the country. It's still a very early stage. But if you were to use those gains to avoid deforestation and to reforest, you could basically cut about 10 years of Colombia's greenhouse gas emissions between here and 2030. So you could actually have this very, very large effect. Let me just finish this way. I'll mention one other thing and then I'll finish. The goal of this model, so this model is actually incorporated into a pretty easy to use web tool. And the idea is we want this institutionalized. So you're not just planning at the national level, you're planning at the regional level, you're planning at the project level, and you can, all the way along the way, you can see, well, if I did X, Y, and Z, how much land could I save? How much greenhouse gas emissions could I save? How much could income go up? How much could productivity go up? And the idea is to create something that makes it possible to merge these political interests. Because obviously, if you're a farmer in Colombia, your primary interest is in increasing production and increasing income. And if you're worried about climate change, your primary interest is reducing your land use change, reducing your direct greenhouse gas emissions. So the idea is to have something that allows you to do those calculations and look at different possible improvements anywhere in the country, so that you can kind of merge that political win-win every time you're actually doing something. So it's not just a big announcement by the president, but it's something that actually gets carried into actual day-to-day activity. That's the goal. And Colombia's still got a lot of changes we need to make. Colombia is actually a huge challenge now because thank God it's going to have this peace treaty, but one of the results of the peace treaty is going to be that they're going to have to resettle millions of people, or offer to resettle millions of people who were displaced by years of violence there. And the easiest way to resettle them is on force. And then there won't be enough money to help them to farm properly. So one of our goals is to hopefully be able to use our tool to be able to analyze where you go and how you can improve. But even in Colombia, one of the issues is, one of the reasons they still have a lot of deforestation is they still have a very basic law, which is common in much of Latin America, which is a law that basically says, if you clear land, you can own it after 5 years. So it's kind of like the American Homestead Acts. And so long as you have that law, you've got a problem. And so obviously you need to have changes, but in order to make those changes, if enough people believe that actually going to benefit more from intensification and extensification. So I'll just leave it at that. I had a kind of last slide on tools, but the bottom line on the tools is this. There are a lot of academic tools of one kind or another to deal with agriculture and climate change. But they tend not to be tools that actually allow you to scale up and scale down. You know, so you have something that allows you to make big global estimates, and then the IPCC can write a report, say we have this much mitigation potential at the global level, and it is utterly useless at anything other than the global level. And actually, if you look too hard, you go, oh. And then we have tools kind of like at the individual farm level for production increases, particularly in developed countries. But what we've been lacking are these kind of tools allow you to scale up and down, which is the type of thing that I think we need if we're going to actually take these opportunities. So, in the best of all possible worlds, could we actually produce all the food that we need by 2050 while dramatically reducing our emissions? Probably yes. It would take some combination of dietary changes. It would take a lot of efficiency gains and a lot of concerted action to protect land use. And part of our work is, can we create the tools that make that more likely to happen? So thanks very much.
Terrific talk. It's amazing how much information you packed in just 50 minutes. I mean, it's really extraordinary, and the linkages, the integration, and the rest of it. The Rockefeller Foundation cites the Green Revolution as one of the 5 major accomplishments that they made. I happen to know the man that hired Norman Borlaug. He came to us in our shop some years ago, and he reviewed that whole thing, and at the end he said, you know, I think I was working on the wrong issue. I should have been working on population. Jump forward to 1995, Lester Brown published a book called Who Will Feed China, based on an anomaly he detected on the grain stocks and so forth. And the Chinese ignored it for a year, and they invited him over with what should they do and so on. Today you see China all over Africa and South America, so much land. I mean, just astonishing what they do. My question, sir, is to what extent does the current president, a reform-minded individual in Colombia, have all this data in his head?
The answer is probably not much, but I suspect, I think there is a general consensus in Colombia that they are better served by intensification as opposed to extensification. As I said, even the Livestock Association came out in favor of that. Why would the Livestock Association not be in favor of both? Well, you could argue, but I think they just have a general sense that, they're very inefficient agriculture, it's very expensive, and if they want to get into the global market, they don't export beef, for example. And if you're going to produce more beef, it's one of the places you want to produce beef, they have to become more efficient. So there is a general sense that they can and should become more efficient. The question will simply be translating that into actual action. It turns out that Colombia has a lot of programs that individually address the various barriers to intensification, but they're not integrated and there are enough resources for all. So for example, more than half of all the farmers, small farmers, don't even have proper title to their land. If you don't have title, you can't borrow money. Now they have a program that started working to get people title, but it takes a long time. Well, similarly, you have some financial assistance and technical assistance programs. So what you want to do is basically our recommendation is to create a priority system that says for those farmers who are willing to protect forests and try to intensify, they get to the front of the line for all the programs that work together to make this kind of intensification possible. So that's our kind of main policy recommendation. So that kind of answers that question. I think there's at a very broad level, there's a kind of an understanding and probably not much below that.
So you're not the first person to speak in this forum who has made the assertion that if all of the land that one could theoretically use and the efficiencies that could be brought forth were in place, that in theory, population could be fed by 2050. Question is, tell me about 2051.
So the reason people kept focusing on 2050 was that a few years ago there was the view was that the population would max out in 2050, around 9 billion. And now that's been adjusted. And now the expectation is continued population growth. But pretty much almost all that population growth is going to be in Africa. So and I don't want to, I actually think we have enormous challenges that I don't want to be overcoming, particularly in Africa. So in Africa, we asked about population. In a simplified term, pretty much the whole rest of the world, with a couple of tiny exceptions, has reduced fertility rates, except for sub-Saharan Africa, where we still have 5 children per mother. And that means there's explosive population growth, and that could go from 900 million to 4 billion by 2025. So Africa is really this just gigantic challenge. And I think Lyndon will be able to talk later on this semester about work that we're doing together to try to say, well, if you're going to have to expand land in Africa, can we target at least where that will occur? And so the answer is there is no solution to Africa that probably doesn't involve clearing more land. But yeah, so one of the key things that needs to happen are the things that would lead to fertility changes in Africa, and we know what they are. So I just say this is like the best win-win solution of all time: educate girls, keep babies alive.
But this is a supply side argument. It's basically a techno fix.
Let's talk about demand.
No,
I talked about changing demand. Changing demand is
yes. But in fact, for example, in China, beef consumption, chicken consumption is rising astronomically. And as you noted, as people become wealthier, they want to consume more animal protein. The same goes for fish. So the underlying assumption is that it is a humanistic one. That humans are ipso facto good, desirable at the expense of everything else in the ecosystem. That assumption begs the question. And that supply side, technology-driven approaches should do their very best, for reasons I don't understand the short word, should do their very best in order to satisfy such implicit requirements. I mean, this is a club with growth rather than a club with Rome approach to the world.
You should do both. My answer is you've got to try to do both. But if obviously you have demand and you don't meet it by increasing yields, you need it by clearing more forests. And the other thing that will happen is that some people won't get enough food, and the people who won't get enough food are to us. So an idea that somehow or other you constrain food supply as a method of holding down food demand, unfortunately that's grossly inhumane because we outbid the poor for food. So whenever there's a shortage of food, the people who suffer are the poor. So we have to, it's an all of the above, and I'm not excessively optimistic. If you actually ask, what are we likely to do by 2050, I'm not excessively optimistic. I'm simply saying that if you wanted to solve the problem, we will take a combination. So one of the things we will do with this Globe Agri model is give you a lot of different scenarios of what combinations of demand changes and productivity changes could reach the promised land. Other people who've looked at it up till now generally think you have to have big demand changes. And I think we'll probably conclude the same. Our model is actually a lot more detailed than other models. And so it'll be interesting from a biophysical standpoint. So we'll be interested to see what we come up with. Others have worked on a very kind of aggregated basis. And some of our results are different.
I've periodically read in the literature about attempts to make meat-like products by synthetic methods, which eliminate a lot of the problems associated with the livestock industry. Do these hold any hope, or are they just pie in the sky.
No, I think they hold
Beef
hope.
in the sky.
So I think they hold hope. So I'll give you an updated answer. I'll give you one answer and then an updated answer. So my original thought has been, look, soy products have been improving, and you don't need to ask people to eat 100% soy burgers. Just get them to mix in soy, fake beef for half of your burger. And that's, I think, a very realistic option. But actually, if somebody came by WRI and who's producing an artificial hamburger the other day, and actually the colleague of mine there ate it, he said it really tasted like a burger. So I have not been optimistic about these other things. Now, the idea of growing meat in a test tube, forget it. Ridiculously inefficient, expensive. That's not what's going to happen. So you get some articles about literally trying to grow meat. But there are ways of simulating meat that I think people are willing to eat. But having said that, I mean, a key message I keep emphasizing is, yeah, chicken is nowhere near as bad as beef. I mean, beef is off the charts in its emissions and its land use demands. And yeah, the average American has already reduced beef consumption by a third from a peak. So I think there are opportunities to change diets. It's a question of whether we take it seriously. Okay, I think probably we'll let everybody go who needs to go. And, thanks for coming.
I have no idea what it looks like. Basically, what is sustainable? That's one thing.
It's easy.
Oh,